All right, so in this chapter, what we're going to be looking at is we start looking at another measure of describing the data, and we look at the mean as a measure of centre. So the mean, which often is that symbol there, is a measure of centre, okay? But we can only use it if it is symmetric data. And so what that means is, so if it's the bell shape or whatever, so we're going to be looking at that. Because if you've got to remember how we calculate the mean. So if we look at how we calculate the mean, remember we add up all the data. So you add up all the data and you divide by how many there is. Yeah, so it's sort of like in general terms, we call it the average, don't we? Like when we're talking about cricket, average runs and stuff, how many runs you made over whatever. So it's the average. So remember that. Remember I said the average can be affected by extreme values. So remember if I said I was taking the average of all your weights, remember if I said if you get someone who's really, really, really large, it makes your average go up, doesn't it? Yeah? But remember when we talked about the median, remember the median is just where when you write all the numbers in order, it was just the one that sits in the middle. So it doesn't get affected by those extremes. So that's why we are going to only use the mean for symmetric data. So if you remember, you might just put a note if you've forgotten, so remember symmetric is that bell shape. There's it's all in the middle, sort of that bell. All right, so we're going to we'll be using the mean, and we'll also be using standard deviation. So standard deviation, you might just want to pop the symbol that they use in the calculator next to that, and they use S with the little X. So that's where you'll find it in the calculator. We never have to manually calculate the standard deviation, so never worry about that. Okay, so here we go. So how we said before, there's measures of centre. So the median is a resistance statistic, so it's not affected by outliers. So for the median, it's really good for use in skewed data. So here, remember when it looks like that, that's positive skewed, or if we have data that looks like that, which is negative skewed, okay? So what happens, remember we have those histograms that look like this, okay? So when you find the median ends up, because you put the data, the median it'll be in amongst where all the data is, in the big chunk, okay? If you've got skewed data though, that's what I was saying, if you were finding the mean here, the mean will be different. This high value up here drags the mean up. So the mean would be above the median in positive skewed data. And when you have these really light, little, low outliers, that means in negative skewed, your mean would be here. Okay? So that's why it's not a good measure of centre for skewed data, the mean, because you can see the median is where it's all happening, so that's why it's good. But the mean for symmetric data, so we can see here, will be really good. So if you have symmetric data, you're going to see the mean is here, and you also see the median is also there as well. So it doesn't really matter which one you talk about, but now we're going to use the mean because we can use some other tricks with it as well, with the standard deviation. All right, so also we've talked about, when we talked about box plots, we talked about the Q1 and the Q3. They're also resistant of those extreme values because it's when you place them in order, all right? So here, this is just another picture of what we just drew up there. So the symmetric and that. So sometimes if you're a little unsure whether data is positive skewed or negative skewed, you can have a look. If the median is much lower than the mean, then it's probably positive skewed. If the median is much higher than the mean, in value, then you could probably say it's negative skewed. And that could be a fact you could use to debate that. All right, so standard deviation, as I said there, it's found on the calculator and it's in that symbol SX. So when you pop in your list in your calculator, so you've got a list of data, you know, say we had all your weights, whatever, and you've listed them all in. Remember when you do stat calculations and all that, you would find all the data. You find the mean, you'll find standard deviation, you also find the 5-number summary. So remember all that? That's all found there. So we give you the formula for the standard deviation just because you've got it in your notes. I've never seen a question, but years ago they used to maybe question which is the formula for standard deviation. They don't really do it now. Okay, so what I wanted you to do here is pop in these numbers in the calculator. So the amounts in dollars spent by 7 customers at a 7-Eleven store were there, and I want you to calculate the mean and the median and to 2 significant figures. So let's do that. I'm just pausing. So we've popped them into the calculator. We've found the mean was 3.6 and the median was 1.7. What does the mean or the median give the best indication of money spent? Well, we had a quick look at a box plot and we could see that this number was an outlier. So because there's an outlier, the mean is no good. Okay, so which one's the best indication? So we're going to say the median is the best indication of money spent, and we'll say because there is an outlier. Because the data actually looks symmetric except for that outlier. So even if we've got an outlier, we're not going to use the mean either. Okay, so calculate the standard deviation to 3 significant figures. So on our calculator that we've already got up, we're just going to go look at that, find the SX, which is right at near the start. It's about line 5. So I've got it at 5 point. Now we want 3 significant figures, so 7, I'm going to say 2. Would you all agree? Yeah? All right. Calculate the 5-number summary. So once again, we can use we're in the same spot on our calculator. You can just pop it up. So the minimum is 0.8. Then you write the Q1, which is 0.8. The median was 1.7. Q3 was 2.65, and the maximum was 16.5. Just remember with the box plots remember your maximum is still the outlier. And remember your whisker would have to go to the next one underneath that. Okay, so now it says draw a box plot. So you simply can copy what your calculator does. So you would need this number line. You rule the number line. It's going up to 0 to 16. Sorry, you've got the dot there, and then you just draw. This one actually doesn't have any whiskers, and just hover, and then just pop the data on the top, if you like. 1.7, and what was the final one? 2.65. Okay, easy to do a box plot, but just make sure you've got a ruled number line, and it's all that, and you get the full points. Okay, so we're testing for the lower fence, good point, which is Q1 minus 1.5 times the IQR. So with the data we've got, it's 0.8 minus 1.5. Now the IQR is Q3, which is minus Q1. So we do that on our calc and get, okay, so I got negative 1.9, I'm just going to write 98. Okay, so anything lower than that was a lower outlier. We didn't get anything because I'm actually talking about money, so I don't think a 7-Eleven's going to loan you anything. So we would zero anything. There's no lower outliers. Now the upper fence is you do the Q3 plus 1.5 times the IQR. So that's where we go 2.65 plus this 1.5 times that bit again. Okay, so when we do that, we get a number, and any number bigger than that is an upper outlier. So we're going to see that it was 5.43. So therefore that's why the $16.50 was an outlier. And we saw that on our graph. If the amount of money spent by each customer was increased by $2, which of the following stats would not change? The mean, the median, the IQR, the range, the standard deviation. Use your calculator to support it. So what you think, let's think about it. The mean, is that going to change? It is, because you add them all up, aren't you? Is that true? So we're adding more $2 to everything. It's going to be higher. So I reckon this will change. Do you agree? Now let's think about the median. Now the median is where, when you place them in order from lowest to highest, it's the middle thing. Now if you put $2 on all of them, it just shuffles them all up. The same one will still be in the middle, won't it? Would you agree? So, but it'll be $2 more. So which of the following, so it'd still be $2 more. It's just going to shuffle up. Would you agree? Yeah? So the median's going to change? Yeah? $2 more? All right, so we'll go median. We'll change. What about the IQR? Yeah? Do you think that'll change? Yeah, because they're all moving up, aren't they? If they were all scaling up, it's going to be a different amount of number. Now, will the range change? No, because they all got the same amount added, so there's the same difference. Would everyone agree? So the range stayed the same. Now, standard deviation, did that change? Well, if you have a quick look back at that standard deviation formula, it uses the mean. So if the mean changed, then our standard deviation is going to change. So we'll just go with that's going to change as well. So standard deviation will change. So which one didn't was the range. So which of the following stats would not change? It was just the range. It stayed the same. Okay, the shop owner realised that he made a mistake when he wrote down the money spent. The $16.50 spent should have been $1.65. Which of the following statistics would not change? Now, you've got to remember $1.65. So how about you guys go play with it and have a look on your calculator and have a look which one doesn't change. I'll come back. All right, so we see the mean, this changed. The median stayed the same. So did the IQR. See how they were resistant to that extreme, so it didn't make a big difference. The range would have changed for sure, and we saw the standard deviation change. So I've seen multi-choice questions on that where they ask you which one would change.